At the center of our galaxy lies a force unlike anything we've ever known, Sagittarius A, a supermassive black hole. For years, scientists have tried to understand it, but its secrets remain hidden. Recent discoveries are starting to reveal a deeper truth, challenging everything we thought we knew. What happens beyond its event horizon, and what's really inside Sagittarius A? The answers might surprise you. Sagittarius A is not merely a dark spot in the sky. It is the beating heart of the Milky Way. It's a force so immense that it dwarfs our entire solar system, with a mass that is millions of times greater than the Sun's. And yet, despite this overwhelming size, it remains invisible. The matter within it has been drawn into a singularity, a point of infinite density where the laws of physics, as we understand them, seem to break down. For centuries, the idea of a black hole was purely theoretical. Only in the 20th century did we begin to suspect they might actually exist. Since then, we've gained glimpses into their nature. But Sagittarius A is unlike most black holes we've studied. Its quiet, dormant state has made it one of the most enigmatic objects in our galaxy. To truly understand Sagittarius A, we must first understand the nature of black holes themselves. These cosmic giants form when massive stars collapse under their own gravity. As they do, they warp space and time itself, creating a region from which not even light can escape. This is known as the event horizon. Beyond the event horizon, time slows, space curves, and reality becomes something entirely different. Inside the black hole, the matter collapses into a singularity, a point where density becomes infinite, and space-time as we know it ceases to exist. But Sagittarius A stands apart. Unlike other black holes that actively devour surrounding matter, it has been relatively quiet in recent years. Its calmness has left scientists with more questions than answers. How does such a massive black hole remain so still? What happens to the material it consumes? And what truly exists at its core? Recent discoveries, however, are beginning to shed light on these mysteries. Using advanced instruments like the Chandra X-ray Observatory and the Very Large Array Radio Telescope, astronomers have observed unusual emissions coming from Sagittarius A. For years, scientists suspected that the black hole might produce a jet of high-energy particles, a feature common to many other supermassive black holes. However, the evidence was incomplete, with various studies providing contradictory findings. Now, for the first time, the presence of this jet has been confirmed. The data reveals a stream of high-energy particles being expelled from the black hole, moving at near light speeds. This jet is not just a byproduct of the black hole's consumption. It provides valuable clues about the direction of Sagittarius A's spin axis, giving us insight into its long-term growth and the forces that shaped it over billions of years. This discovery marks a turning point in our understanding of the black hole. The jet not only tells us about the black hole itself, but also the way it interacts with the galaxy around it. It suggests that Sagittarius A may have influenced the structure of the Milky Way in ways we are only now beginning to comprehend. The implications of this discovery extend beyond the black hole itself. The jet we are now observing is a direct link to the history of Sagittarius A. Its spin axis, aligned with the rotation axis of the Milky Way, suggests a steady accumulation of material over 10 billion years. This alignment is critical as it points to a gradual and consistent feeding of the black hole over cosmic time. However, not all of the mysteries have been solved. While the jet reveals much about the black hole's activity, it also leaves us with more questions. For example, the jet appears to be weak, perhaps because Sagittarius A is currently consuming very little material. We can only speculate about the conditions that might cause it to flare up again, as it has in the past. We know that Sagittarius A was once far more active. In fact, centuries ago, it was a fierce consumer of matter, emitting far brighter jets than we observe today. The quiet state it's in now doesn't mark the end of its life, but rather a temporary pause. When this black hole stirs again, it could unleash a new cycle of activity, and the jet could once more shine brighter than ever before. Despite all that we've learned, there is still much we cannot understand. We know that Sagittarius A is a cornerstone of the Milky Way's structure, influencing the movement of stars, the formation of new ones, and the dynamics of the galaxy itself. Yet the black hole's core remains a place of mystery, where the known laws of physics no longer seem to apply. One of the most intriguing aspects of Sagittarius A is its silence. While other black holes are active, tearing apart nearby stars and gas clouds, Sagittarius A has remained relatively quiet in recent centuries. This only adds to its mystique. What does this quietness mean for the future of our galaxy? What is it preparing for, and how will it shape the next chapter? In the story of the Milky Way, as we continue to study Sagittarius A, we are left with more questions than answers, but each discovery brings us closer to understanding the true nature of this cosmic giant. And though the black hole's deepest secrets remain locked within its event horizon, we are certain that, in time, the answers will come. For now, we can only look on, in awe of the power, the mystery, and the elegance that lies at the heart of our galaxy.